Hello everybody. In this first video I will review main concept of chapter 9. So what did we talk about in chapter 9? We talked about inferences about two samples, and the most common question that I get asked is, how do you know which problem is dealing with which type of test? Okay, so the first thing that you guys want to do is ask yourself this question: what type of data am I dealing with? Is it categorical or is it quantitative? Okay, just really read the problem very carefully and decide, is my data measured in units? Is it height, weight, distance, salary, and so forth? Can it be described with some units? If that's the answer, then you're dealing with quantitative data. Okay, if it's not, then it's categorical. So let's go ahead and start with categorical. If that's the case, you're dealing with the difference between two proportions. You can assume that in this case, you're dealing with independent samples. So what are you going to have? You're going to have two samples, x1 and n1, and then that will produce some proportion, p1, and then x2 and n2, that will produce proportion P2. Now, what is these x1 and x2? This will be the number of people or individuals that have a specific characteristics that we're interested in. For example, females among students, okay, or part-time students among all students at FCC. All right. Then your null hypothesis will always say that there is no difference between the two proportion, okay, or P1 is equal to P2. The alternative hypothesis will say, well, there's a difference, and depending on what the setup is, it will either be the not equal, P1 is greater than equal to P2, or less than. Okay, so when you're dealing with categorical data, you can assume that your samples are independent, and then what are the commands that you need to be using? Either two proportion z-test or two proportion z-interval, depending on what the problem is asking you to do. Okay, now what if you're dealing with quantitative data? If that's the case, here are two scenarios that you have to consider. First, do you deal with independent samples or paired data? All right, how do you know? Independent samples, a lot of times it will just say these two samples are independent, or a good indicator that two samples are independent if your sample sizes are different. Now, that's not always the case. Okay, so that's not always true. They could be the same size and still independent. All right, so then you ask yourself this question: is it paired? Can I separate my data points? The answer is yes. Then you're dealing with independent samples. Okay, now paired data comes in pairs. Since paired, that's something like before and after, or maybe questions about husband and wife. So the data points that cannot be separated, and when you plug them in L1 and L2 in your columns, you have to follow the order. All right, now this is very important. Try to figure it out which one is which, because the calculator commands will be different. So let's say you're dealing with independent samples. Okay, then what are your null hypotheses? The null hypothesis will always say there is no difference, the two things are the same, and then the alternative will say, okay, they're either not the same or one is bigger than the other. If that's the case, you're dealing with two sample t-test or two sample t-interval. Okay, so if you have the raw data, meaning all of the numbers are given to you, then you carefully plug them in L1 and L2, or whichever columns you decide to go with, and then you use these commands to make inferences about these two samples. Okay, so that's what you do if you have independent samples. Now, what if you have paired data? All right, so something like before and after. Then take a look at it. This is a little bit different. The notation here says is mu of d. That says the difference. So the mean of the difference is either a 0 or a number. Okay, so don't assume that it's automatically 0. Read the problem carefully and decide what the number that needs to go in there. Now, a good example of a problem where you don't have a 0 is on activity 9, problem 2, I believe, where we had this preparation course, and I think they were claiming that the scores increased by over 60 points or something like that. Okay, so 0 is not necessarily the number that's going to go here. So the alternative, the null hypothesis will always say, okay, well, that's the number. Most likely it's 0. Sometimes there will be some number. And then the alternative hypothesis will say, no, it's different. It's either not that number or just greater than or less than. Okay? So that's the setup. And then what do we do? Here, the most common mistake that I see is forgetting that you're dealing with the difference. So if you have your data, plug it in L1 and L2, your actual data, and then find that difference. Okay? Find the difference and then store it in L3. Okay? Or whichever column you decide, it doesn't really matter. And then t-test and t-intervals will be done on the difference on L3. Okay? And that's the most common mistake that I see. All right, forgetting that you're actually dealing with the difference, not with the two sets themselves. Okay, over here, if you have independent samples, you don't need to find the difference by hand. Okay, so these are your setups for the 3 types of problems, right? Again, let's go up here. First thing, decide which type of data you're dealing with. If it's categorical, you're dealing with proportions. If it's quantitative, there are 2 scenarios: independent samples, paired samples. And then once you know which the setups you have, then these are your commands here. Okay, now just like before, if the p-value is small, if the p-value is less than alpha, then this evidence is surprising, right? We reject the null hypothesis. What does that mean in the context of the problem? That means there is a difference. There is a difference between 2 samples, right? Okay, if the p-value is large, bigger than alpha level, we fail to reject H0. That means we cannot conclude that there is a difference, right? Okay, there might be, okay, but looks like the 2 samples are not different enough. That's what that would mean. All right. Okay, so this is the first part of your review, and the next one will be coming up in a minute.